Well, good evening, everyone, and welcome to the Role of Immunity. I want to thank everyone for taking the time out of their busy schedules to get on this webinar and take an opportunity to learn more about the immune system. This is certainly a conversation that we have all had to learn more about of recent. And I want to start out just by letting you know I don't have any intentions of reiterating or speaking verbatim to the things that you've probably already heard. What I want to do as I go through this presentation with you tonight is I want to give you an opportunity to really understand how the immune system works, and then I want to present some novel approaches to really bolstering your overall immune system. And these are things that I think will be different than what you've heard, but I'm also going to show you as I go through this that these are certainly founded in science. These are not things that I just came up with on a whim. These are things that are certainly credible recommendations for you to follow to bolster your immune system. Let me just also, as I start out here and say, is just for the interest of everyone that's listening tonight, and for those that listen to this recording after, if everyone could just mute their microphone so we don't have any background noise for others. So just real quickly, if you aren't familiar with me, I'm Dr. Arland Hill, and I do appreciate having you with me tonight. Just to give you a quick snapshot of who I am, I've been practicing functional medicine and functional nutrition for the last 2 decades now. Been in a lot of different clinical environments, had a chance to integrate with a lot of other professional types. That's given me good observation of the healthcare landscape. That being said, I also own and operate Harvest Hills Ranch, which is a completely regenerative ranch, which I will, you'll see why that has relevance for me sharing that with you as we get further into this conversation. But I said I wanted to start off by giving you an idea of what the immune system is. And I do want to do that. I think it's important to have a working context of what we're talking about. Sometimes we use the terminology of the immune system somewhat generically, and we really need to think about it at more of a specific level to have an understanding of how to take action with it. So in short, it's a complex network of different cells. I'll detail some of those for you. There's different organs that are involved, but the main goal of that system, as we know, is that it's to defend against infection and other foreign agents. To give you an idea of some of the main players in the immune system, we have the white blood cells. And even within that category, we can start to subset there and recognize that there's 5 different types of white blood cells, and each of those have their own independent, unique roles. I am going to share some characteristics of some of the more relevant ones with you tonight and help you understand what those do, but they don't act by themselves. We also have antibodies. That's a term we've all probably become a bit more familiar with. One that we probably are less familiar with is the complement system. This is part of the system that allows us to develop very specific responses in our immune system. We also have the lymphatic system, the spleen, the bone marrow, and the thymus. And these last two, the bone marrow and the thymus, I personally don't think either one of these get nowhere near the attention that they deserve, especially the thymus. The bone marrow is going to be the source of production of our immune system cells. And so that area certainly needs to be healthy. It needs to be productive. It needs to have the resources necessary to produce those red blood cells on a consistent basis. And we bring into that conversation the thymus, and there are specific types of immune cells known as T cells. And these T cells can differentiate into various subtypes, but they all come from the thymus as well. And the interesting thing about this is that when you look at things like bone marrow and thymus, I'm just kind of thinking off the cuff here for a minute, and I'll throw a concept out to you that I just thought about. And even the spleen comes into this conversation as well. These are all things that if you look at these from a historical standpoint and think about our food supply and how we ate in years gone by versus how we eat now, those are actually things that would have been part of our diet. And so the question becomes, well, we don't get those things in our diet anymore. So how do we continue to support these tissues? It's extremely relevant when you talk about the thymus tissue, because The thymus tissue, the functionality declines with age. We know that in our later years of life, we don't tend to have good thymic tissue, but that doesn't mean there aren't things that we can do to change that. And so some of what I'm going to share with you tonight comes directly into this conversation as well. Now, the thing about the immune system that is a bit interesting is that in certain cases, we have connection to the organ systems in our body. So let me provide an example on this. When we think about our heart, we can feel our heartbeat sometimes. We can even hear it maybe at times, but we can certainly put our hands on our wrist or on our carotid arteries and our neck, and we can feel that our heart's working. We can feel the blood pumping. The immune system, however, unless you come into contact or unless you are suffering from some type of infection, your immune system's being overwhelmed, you generally don't pay any attention to your immune system. It's relatively silent, if you will. But it is bar none the system that has to be most active because it can never take a rest. It has to constantly be on guard. If we just did samplings in our environment, we would recognize that there are numerous bacteria and fungus, all these potential alarms to our immune system that cause it to react. And so therefore, it can't ever go to sleep, so to say. It can't ever take a vacation. It needs to be on alert all the time. Just to share some clinical insight with you, this is also one of the reasons that I choose to look at nutrients in immune system cells, is because those cells have to be highly productive. They are always looking to adapt and looking to change. And if we don't allow them to do so, then they're not going to be able to respond in an efficient manner like we would need them to be able to do. So it's extremely important that the immune system have the resources that it needs. Now, let's talk about this in regards to the first line of defense. And this is where I want to start to segregate the immune system into different components to help you understand how the whole process of developing a response to whatever the stimulus is by your immune system. So like I said here, the first line of defense is what we call the innate immune system. It is the inborn immune system, if you will. It has several different ways of trying to elicit a protective response. But the key point about the innate immune system is that it's non-specific. And that doesn't matter if it's dealing with a virus, a bacteria, a fungus, some type of parasite, whether that be a worm or a protozoa. These responses are all non-specific. And like I said, there's a number of defense mechanisms that come into play here. So this isn't just about simply the different immune system cells. This is bigger. Remember, there's other parts of your immune system beyond just the immune system cells. So for example, we think about the different physical barriers in the body. The most obvious one of those is going to be our skin. But you also have physical barriers in your air passages, in your lungs, in your nasal cavity, in the mouth, in the gastrointestinal tract. These are all barriers that they're critical components to the immune system. And again, this innate immune system, because as logic would have it, especially when you think about your skin, that's a first line barrier. And so it needs to maintain its health and its integrity. But what we often tend to overlook is, as opposed to just the structural barrier that exists there, is that there's also a protein component to this by which we produce these, we'll call these antimicrobial proteins, if you will. And the idea with this is that the different microorganisms in these environments have the capacity to be able to establish a chemical barrier by producing these antimicrobial proteins. And the goal of those proteins is to inhibit growth of organisms that otherwise shouldn't be invading or harboring themselves in the body. So we want to make sure that these different organisms are nourished, that we're not doing things that are going to be of detriment to them, because again, they're first line defense, right? So if we break through that first line, now we're having to call in the backup resources here. So let me delve a little deeper into each one of these protective barriers that I mentioned here. So again, I want to look at the skin, because the skin is one that often gets overlooked, and I think that there are some things I'm going to share with you here as it correlates to what makes up the skin and how your diet plays into this conversation that can ultimately build some real profound defense systems for you. So first of all, just as we look at this, when you think about the skin, there's a lot of layers of cells there that are, as the term implies, they're layered on top of each other. And the skin, by virtue of that layering system, is one, just going to create a barrier. But the other thing that it does here is that there's secretion of fatty acids and enzymes into our skin as well. And one of the fatty acids that comes into this conversation is oleic acid. Now, oleic acid, that term may not resonate with you here initially, but I'm going to share some terms with you, or some sources with you, of oleic acid that will resonate with you. And so let me give you three here. And so the first of these is going to be olive oil. Olive oil is very rich in oleic acid. The next one is going to be avocado and avocado oil, also very rich in oleic acid. I have a slight preference there for the avocado, the food itself, just because there are some additional benefits that the avocado as a whole has that we don't get from the oil, one of those being glutathione, which directly correlates to our immune system functionality as well. So that's the second one. And then the third one are macadamia nuts. And macadamia nuts are extremely rich in oleic acid. And this is a fatty acid, as I mentioned, and it can kill certain bacteria through an enzyme that it produces. So when there's an enzyme that exists in that oleic acid as a component within these foods, and we use that enzyme to help degrade these organisms that otherwise shouldn't be there. Now, again, just as a point of reiteration on this, remember, you do have these mucosal barrier systems in the lungs, in the gut, and the urinary system. There's mucosal barriers there all as well. With everything we've heard in the immune system lately, we can certainly appreciate the respiratory correlation to this, but you would also have to even more so appreciate the connection to the gastrointestinal tract, and recognize that if that barrier in the GI tract breaks down, you've literally just opened Pandora's box into the rest of the body, because now the immune system is not competently responding. And remember, the immune system is not isolated to one region of the body. It's not like the heart or the liver, where it just has a coordinates that it's located in. This is constantly migrating throughout the body. And so we need to pay extreme attention to those. And this is one of the reasons that you've heard conversation and seen so much conjecture out there about zinc. Well, one of the things that zinc does is zinc is going to be beneficial for moving vitamin A around in the body. And vitamin A is critical to maintaining these barrier systems. And we really, I'll just give you guys a way of quickly assessing this for yourself. If you look at your fingernails, just look at your nail beds, and if you see white spots on your nail beds anywhere, that's what's known as leukonychia. And that's an indication that you most likely have a zinc deficiency, which further, again, would suggest that you're not going to use your vitamin A efficiently, and these barrier systems are likely going to start to falter at some point. Now, what about some of these cell level responses? Let's go back to the cells here for a minute. And these are crucial in innate immunity. We have to have them there, and they're not the structural physical barrier. They're more in line with establishing the chemical barrier. So we have a structural barrier, we have a chemical barrier here. And this is really where, I guess really, if you think about this from the structural side, I just gave you the example of zinc and vitamin A, and there are other nutrients that come into the conversation when we start talking about these chemical barriers. But not to digress, let me share a few other things with you here. If microbes that you're encountering, whether these are, again, bacteria, fungus, viruses, parasites, doesn't matter. If they breach these protective barriers and they actually start to find themselves interacting with the internal tissues in the body, this is where you're going to begin to see more of a response. So this is taking that innate immune system to the next level and asking for it to start to respond at a different intensity. There's many mechanisms by which these cells can begin to do this, but the intent here is to use these non-specific responses to create harm and destroy these organisms that otherwise really shouldn't be there. It doesn't mean that we shouldn't come into contact with these. It doesn't mean that they're not going to present a challenge to us from time to time, but the innate immune system by and large is going to handle the majority of these types of threats that for the most part we just don't perceive. Now, let's talk about some early induced responses here, and this is the final process of innate immunity that we're going to delve into here today. Many of you are familiar with the response but may not have heard of the dangers it can pose. This is quite simply nothing more than inflammation is what we're talking about here. So I always think about with the immune system and inflammation, many individuals like to try to separate these two things. And the reality is that these are one and the same. Inflammation is part of how the immune system operates. It begins to come into the conversation as the immune system begins to progress in its activity in terms of trying to mount more significant responses. And it can help eliminate an infection and hold it in check in a lot of cases. But many times once this inflammation begins to cross a particular threshold, this is where we start to find that we're going to begin to manifest what's known as the adaptive immune response. And so hold on to that thought for a moment. I don't want to go there just yet with you. I need to stick with the inflammation here for a minute. If you're talking about inflammation, if you think about things like some of the most common signs of inflammation, things that we think about like pain or swelling or redness or fever, those are all things that are induced by a class of our immune system cells that are very nonspecific in nature. And what we want to appreciate is that while we tend to think about those things when we have an injury, the reality is that those same things are occurring on a much more microscopic scale when our immune system is insulted by some type of infectious response. And in general, if the inflammation is presented and then it starts to go away, we don't worry too much about it. But the problem is when it continues to linger on and it becomes of a chronic nature, that's when we see issues with the immune system really begin to manifest. Now, let me show one thing here to you on this second line of defense. And this is where we start to talk about the acquired immunity. This is the next level. So let me recap here for you for a moment. When we started out, we had these non-specific responses. There's a group of cells that are always lingering out there in our circulation. They come in contact with a threat and they try to neutralize it. Okay, well, what happens when they can't neutralize it? Well, in that case, that's where we bring in the acquired or the adaptive immune system. It goes by a couple of different names, but we're going to use those two interchangeably tonight. And this is not what you're born with. This is what your immune system develops over a lifetime of interaction. So when you're exposed to things, let's say you're exposed to a pathogen in your environment and you want to be competent at dealing with that pathogen. You know, maybe the first time you come into contact with that pathogen, it really challenges your immune system and runs you down. But the next time you come into contact with it, if it's the same pathogen, your immune system has already developed a well thought out, planned out response, and it can dive in there and start to deal with it. So, you know, this is really where when we talk about the chronicity of some types of infections, or we talk about other challenges to the immune system, for the most part, this is the area that we're really talking about a lot of times. Now, I want to share something with you. I mentioned this aspect about inflammation, and one of the things that is certainly a contributor to that is going to be the Western diet. And notice what actually happens here. I found this pretty interesting, and this is not old information. This actually just came out in the summer of last year. And what you'll notice here is that the Western diet consumption activates the innate immune system. And so this is that non-specific response that we're talking about. But look at what else it does. It impairs the adaptive immunity. So when your immune system is developing that initial response to these foods that are coming in that by and large are not truly foods, they're food-like substances at best. They fall under categories of processed and ultra processed. But ultimately, what these things are doing is they create an immune response, but they don't allow your immune system to move forward with trying to adapt and overcome these challenges. And that's a crazy way to think about that, of thinking of food as a negative challenge to your body. But ultimately, what begins to happen is that you see that chronic inflammation sets in, and your ability to deal with your viruses becomes limited as well. And so in reality, this set of information only was paying attention to viruses, but we know that this would happen whether we're talking about a fungus, a bacteria, a parasite, any type of microbe. The ability of the immune system to develop a response to that is certainly going to be limited. So let's go a little bit deeper here. And one of the things I want to note is that it's certainly well established that individuals who contract certain diseases and survive, they generally don't contract those diseases again. And this goes back to the whole memory aspect and all the activity that the immune system goes through in developing this acquired response. When your immune system is exposed to a pathogen, it has the ability to learn it. It wants to recognize it. It's data banking that information that it's picked up from having to fight off that type of germ, so that if that particular organism rolls around again, you're in a much better position to be able to handle that. Your acquired immunity is dependent on specialized cells. These are known as lymphocytes. And the nice thing about these lymphocytes is we can do a simple blood test and look at these. In fact, probably the most common test ordered in all of healthcare, a complete blood count, shows us these lymphocytes. And these are cells responsible for the body's ability to distinguish and react to almost an infinite number of foreign substances that we come into contact with. So this even extends outside of microbes. And we start to think about toxins in the environment and how do we work to eliminate these toxins. The lymphocytes come into that conversation as well. And so let me share a bit more with you about these guys. I mentioned earlier how important the bone marrow was, and lymphocytes are ultimately derived from the bone marrow. They need some type of stimulation. So when I talked about that generalized immune system response a little bit earlier, one of the things that they do, in addition to trying to eliminate the substance or the organism that they find that shouldn't be in our bodies, they also send out messages to the more adaptive or the acquired immune system, and specifically these lymphocytes. So essentially, it's a call for reinforcement is what it is, right? So an initial set of troops came in and they got overwhelmed, and so now we're calling in the reinforcements to back us up with, and that's who the lymphocytes are. By and large, these guys fall into two categories. We talk about them as B cells and T cells, but they serve different roles in the bodies. Some of them are going to be in relation to producing antibodies. Some of them are going to help us differentiate whether there's a problem inside of a cell versus outside of a cell. So for example, viruses being a problem inside of the cell, and bacteria for the most part being an outside of the cell issue. So our immune system needs to differentiate between that, and it needs to be able to develop the appropriate response depending on whether it's inside or outside of the cell, and the lymphocytes are what are going to help us do that. Now, there's also these things known as receptor molecules, and tying this into the lymphocytes, these lymphocytes are distinguished from other cells by their capacity to recognize these foreign particles or organisms by means of these receptor molecules. And so what they ultimately do, they're the lock and key mechanism, if you will, and they are what allows specialized proteins to ultimately bind to different cell types and communicate efficiently. Now, why am I going into this with you? You guys are probably thinking this is some doctor speak here. We're starting to get into the weeds. I'm not going to get too far down this trail with you, but what I want you to see from this is that these are all proteins. And so the amount of protein that the immune system needs, it needs an adequate amount of protein to be able to competently build these structures, whether it's antibodies, whether it's these receptor molecules, whether it's the tissues that are producing these cell types that we're talking about. These are all derived or can all be derived from the diet. So diet doesn't get much conversation other than to say, eat a healthy diet, which what does that actually mean? Especially when there's so much information thrown at us from varying opinions about what that actually is. In reality, we need to eat for what our metabolic needs are and forget all these named diets that are out there. But the reason, again, that I'm pointing this out is because those at a cellular and molecular level, the right constituents in our diet influence things like this receptor molecule that are ultimately going to allow those lymphocytes to perform at a much higher level. Now, let's talk about record keeping here for just a moment. And this is one of the many incredible abilities of the immune system, is that it can literally record keep and data bank everything that it has come into contact with and had the ability to overcome and defeat. And if you just think about even on a daily basis, how great that number is. And as we go through changing seasons, and so we typically go through the cold and flu season where viruses tend to be more prolific, or you go through allergy season in the spring and in the fall, these allergens are part of what your immune system is data banking. It is unbelievable how much information your immune system can store and ultimately just bring right back up to the surface and develop a protective response against that stimulus when you encounter it again. This allows the immune system to be able to quickly recognize, it can destroy whatever comes into the body that ultimately shouldn't be there. And so when we run into these various types of infections, these different viral strains, and this is something interesting too in the context of viral strains, and what we hear is that it's not a perfect system, but we hear about, even with the flu, every year you hear about the new variation of the flu every year, and the flu does do that. It's a quickly mutating virus. It's the nature of a virus, quite frankly. But your immune system can use information from one variation to effectively respond against another variation. Now, does that perfectly happen every single variant? No, it doesn't. But it at least puts your immune system in a better position to be able to handle the numerous threats that it does run into. So let's move from here and let's talk about how we ultimately acquire immunity, because this is going to be an important concept for us to look at as well. And just to give you an idea of where we're at here, I'm over halfway of sharing this information with you about what the immune system does. And then we're really going to delve into these things that you haven't heard. And when I start to share these with you, you're going to see why I went through and talked about the different types of the immune system here. So let me quickly tell you about how we acquire immunity, because this dictates our overall responses. For example, someone living in Southeast of the United States versus someone that's living in the Northwest of the United States or anywhere else in the world, we have different exposures that we come into. We have different things that are going to act as stimulants to our immune system. There's different influences based on our environment on our immune system. So there's two factors to think about that quickly answer this, how we acquire immunity. One is what our environment presents to us and how we handle that. And then the second part of that is what our environment presents to us in regards to challenges that either hold our immune system back or may actually help move our immune system forward. Remember, we have this concept in the body known as hormesis, and quite simply, hormesis means is that a little stress is generally beneficial to the body, but a prolonged stress becomes problematic. And so we don't want these stresses on the immune system to exist on and on, but we do want our immune system to be competent as well. So we do expect to Even the individual that's in the best of health is going to feel a challenge to their immune system from time to time. That's not necessarily a bad thing. That helps us build competency in our immune system. Now, when you talk about the immune system, again, this is just dovetailing right into this concept about variability here. And that's because we're all exposed to the different triggers for our immune system. None of us that are listening to this tonight, and no one that will listen to this after tonight, is going to have an immune system that is exactly the same. They all vary from person to person. Now, there's aspects of them that are all the same. For example, mechanistically, the way the innate response, that non-specific response is carried out, those skin barriers, the transition into acquired immunity. Those are all things that are consistent. But then you get into the conversation around genetics and how genetics can influence various parts of our immune system. I briefly mentioned a molecule known as glutathione. And glutathione comes from proteins in the diet. It's made, we make it from proteins, but some individuals have difficulty making adequate amounts of glutathione, and there is a direct relationship between our glutathione levels and the competency of our immune system. So if glutathione goes up, our immune function goes up, and the exact opposite of that is true as well. So that is going to create some differences between individuals as well. Now, for that individual that doesn't have ideal responses from their immune system, they may become overactive. And so we start to think about a lot of conditions being overactive. The most common one individuals think about are allergies, but autoimmunity plays into this conversation as well. Just to differentiate these for a minute, to give clarity to these, when you have an allergy, anything almost can be an allergen, but the most common ones are going to be foods, medications. If you, for example, get an insect bite, that can be an allergy. And sometimes folks think about this as, I have to have an anaphylactic reaction, or at a minimum, I have to get stuffiness and runny nose and swollen eyes, those types of things. And that's actually not the case. Allergies can present fairly benignly in some individuals, and they may be nothing more than a slight discoloration in the skin, but they can continue to progress above that too, to where we start talking about named conditions like dermatitis and eczema. Now, you go the other route, and we talk about the autoimmune aspect of this. This is really where the immune system has run amok. The immune system has been confused, is the way I tend to think about this. It's a very generic way of thinking about that, because there's a lot of complexity in autoimmunity. But ultimately, the body is starting to attack itself. And there are generally some missing guides, if you will, that are responsible for that. In short, when we talk about autoimmunity, there's quite frankly three things that have to enter the conversation. We have to talk about the imbalance of the microorganisms in the gut. We have to talk about some type of environmental trigger, and we have to talk about some type of genetic predisposition. And interestingly, that last one, while it may seem there is nothing you can do about that, that's actually not the case. There are things that we can do to regulate how your genes influence the activity of your immune system. So all hope is not lost, so to say. Now, that's all overactive. What about underactive? And then we're going to jump into what we're all going to be able to do here. Okay. So an underactive immune system, and this is quite frankly, even though there are a large number of people that fall into those categories that I mentioned with the overactive immune system, underactive immune system is very, very common as well. Probably what most people tend to think about with this, when I talk about this, the most well-known here is going to be something like HIV or AIDS, where the immune system is being attacked by a retrovirus. It can't develop a competent response, and typically an individual in that case succumbs to some other type of systemic challenge. But that's the more extreme level. There's immune dysfunction that happens at a much lower intensity that many people are threatened with, and it can progress on into more advanced states. But ultimately, what starts to happen here is that the immune system is presented with a challenge. And the bottom line most times is that it doesn't have the resources that it needs to build a competent immune response. So, for example, I talked about earlier this differentiation between being able to know whether there's a threat that's occurring outside of the cell or inside of the cell. When underactive immune system is not going to be competent being able to differentiate from that. And also, and I see this actually very, very often clinically, is that simply the total number of immune system cells that are or that should be produced are not being produced. And so right out of the gate, we can look at that. We can say that that's an incompetent immune system. The bone marrow is not functioning at an efficient enough level, and we need to change our thought process in what this person is doing dietarily, lifestyle, exercise. There's any number of facets that we can bring into this conversation, but ultimately something has to change. Now, here's what you've been waiting for. What can we do? Well, we've gone through this in-depth understanding. I've tried to detail with you and change the narrative that you hear in regards to the immune system and make it where it's not this what tries to get painted as a scary concept that your immune system's run amok and there's nothing you can do. But as I'm going to show you, when you have understanding of how the immune system functions, there's actually quite a bit you can do here. And some of the things, like I said, that I'm going to talk about, you're just not hearing these anywhere else. So the ability to overall boost your immune function, it is a bit complex, but it's constantly under study. So for me, as someone who constantly is looking at medical literature and trying to stay on top of this and have better understanding about the nuances of what's going on, it is a very complex topic. But I always find it so interesting that when it comes back to some of the interventions that, whether it was 100 years ago, 150 years ago, or right now, they all still work. It's the same fundamental things that still work. We just have started to have a different understanding on why some of these things do work. And so let's talk about some immune boosting tips here. First off, let's put all this under the context of a healthy lifestyle, right? I don't think anybody is going to push back on me here by saying you can live an unhealthy lifestyle and have a good overall immune function. We know that the immune system is going to benefit from the consistency and routine decisions that we make. And so here's a few that I have for you that I'm going to hit at a high level before I start delving much deeper with you, okay? So when you look at your diet, one of the things that I consistently find that is a challenge for folks that are struggling with their immune system is typically lack of adequate protein. And it's important to put this protein in context. And I'm going to show you a specific example on this, but that protein of a large percentage needs to be of an animal-based nature. And the reason that is because if we look at the animal-based proteins and compare these against plant-based proteins, and this is not meant to be a knock against plant-based proteins, but there are what are known as peptides, which are groups of portions in this protein that are unique and only found in animals and are not found in plants. And they have a direct correlation to how our immune system functions. Does that mean that you can't have a good functioning immune system on a plant-based diet or when you're focusing predominantly on plants? No, it doesn't mean that, but it is going to be more difficult. So we want to make sure that we're getting animal-based proteins in the diet, and we want to make sure that we are consuming those from animals that are consuming their natural forage, because again, keeping this in the context of the immune system, if that animal is not eating its natural forage, if it's consuming a forage that presents higher amounts of inflammatory fats, we talked about the impact that inflammatory or the inflammation is going to have and the detriment that can have to the immune system. So that becomes now a part of the conversation. And if these animals have come into contact with various what I will tend to call chemical toxicants or chemical toxins, these various chemical pollutants in the environment or in our food supply, those are all going to be things that are going to create a confusion to our immune system. So that's one aspect in relation to the diet. And then color in the diet. When we start to talk about different antioxidants, especially those rich, vibrant colors that we find in fruits, those are going to be advantageous. And we do get some of this in the vegetable category as well. And I'm not telling you that to say prioritize vegetables over fruits. They both have attributes here. You just need to understand what your needs are. Now, here's the next one for you. Looking at exercise, there's a key to this. I just had a young lady yesterday, 27 years old, that I was consulting with. And one of my conclusions for her was, you've got to back off of the exercise. It's destroying your immune system. You're 27 years old and you're working out 5 days a week. You're overdoing it. You're overtrained, and we've got to get you out of an overtraining state if you expect to continue to, or if you expect to recover and regain your health. So it can happen at any age, but we want to make sure that exercise is of the right stimulus and that it's not too frequent in nature, and that we give our body a challenge, but we also give our body an opportunity to recover. We want to make sure that we get adequate sleep. I've got a great example of that coming up for you here in a moment of what that's going to do. And that's going to tie us right into a conversation around melatonin. So stick with me here. We're going to get to that. Let me delve just a bit deeper into this diet conversation. This is where we start to appreciate this relationship between individuals that have good, competent immune systems and those that are well nourished. And you can probably, the most extreme examples on this, and these are extreme examples, but I'm sharing this with you to create a mental picture, is if you look at individuals that are malnourished. If you think about third world countries, these individuals tend to succumb to infections and to pathogens and organisms in their environment, things that you wouldn't otherwise see when we start to talk about a first world country, because we generally don't see malnutrition at a macronutrient level. So thinking proteins, fats, carbs. Unfortunately, what we in first world countries run into, which is completely avoidable, are micronutrient deficiencies. So it's not the macronutrient, not the protein, the fat, the carb, not the sheer amount of calories someone's taking in. It's the micronutrients. It's eating food that doesn't contain nutrients like zinc and selenium, iron, copper, folate, vitamin A, vitamin C, vitamin E, all these nutrients that are essential for optimal immune responses. Just to throw a additional comment in here, we hear a lot about vitamin D and zinc, and two nutrients that I have much appreciation for. Unbelievable, quite frankly, the roles that both of those nutrients play, especially vitamin D. But it's a lot broader than those two. So I don't want you to think, as you're hearing the narrative out there, I don't want you to think that those are the only two. We really have to understand other nutrients that come into this conversation as well. So for example, I mentioned copper. You look at the activity of zinc, and we need copper and manganese, another mineral we don't hear anything about. But those two, the copper and the manganese, are just as essential to carrying out some of the immune system related roles as zinc is. You look at vitamin D, and vitamin D requires magnesium. Even when you're supplementing vitamin D, whether you're supplementing it, getting it from the sun, or in the small amount of foods that you can get it through your diet, it doesn't matter what the source is. You have to have magnesium to ultimately get that vitamin D to where it needs to be, to carry it over, to allow it to make its active form, so it can do all the things that we hear about as benefits of vitamin D. But that's what we deal with here in a first world country, right? And so we can specifically look at our own nutrient status to best determine what our individual needs are in replacing those nutrients. Now, let's talk about daylight exposure here. And I wanted to just broaden the conversation a bit on this, and then we're going to keep moving through some other interventions that you can personally take advantage of here. So just note on this, although it is still debatable what level of vitamin D is considered optimal, I'm going to share my opinion here with you in a minute. It's advisable to increase vitamin D intake and have sensible sunlight exposure to maintain your vitamin D levels up into an optimal level. Now, personally, I think an optimal level for most individuals we should be shooting for somewhere between 70 and 100, 40 to 60, 55 and above is really where we've seen the most risk reduction of recent, but I still am not convinced that that is what is considered optimal in terms of all the different roles that vitamin D has. But let me backtrack for a minute to this sensible sunlight exposure, because one of the things that every one of us should be doing, and this is something I have started incorporating more into my own personal routine, is I want to see that first sunlight exposure in the morning. I want to spend some time outside watching the sun rise, getting real sunlight into my eyes as the sun's coming up, to train my brain and train my natural rhythms, and do the same thing in the evening, even during the middle of the day. Now, when I'm behind the computer working, I get up and I go outside at various intervals throughout the day to make sure I'm getting sunlight exposure. And so that's something we should all be doing. And it ties into some of the other recommendations I have for you here in a moment, even beyond vitamin D. Just to give you some idea of all the things in relation to vitamin D here, if you look on the right side of the screen, you'll see where we start to talk about infections. You can see that these are going to be of a viral nature, a bacterial nature. These can have effects with even sepsis, so where we get an infection in the blood. And so vitamin D is going to be very, very profound in terms of what it can do. So this is certainly one we want to continue to make note of. Now, melatonin. This is one that's not being talked about. And you can see graphically here, it's not being talked about enough. Let me put it like that. We can see graphically that if you look at the bottom of this graph here, you'll see 08, that's 8 o'clock in the morning. We go across, and when we get to around 2200 hours, and those of you familiar with the 24-hour clock, you'll note that that is 10 p.m. And we can see that that's when our melatonin starts to peak through the night hours. We all know that. We know that there is going to be a regulation of the immune system by melatonin. And to that endpoint, let me share some mechanisms and sources of melatonin that you may not be familiar with, because in general, we think melatonin is either produced from the pineal gland or we have to supplement that. And both of those are accurate. Both of those are true, but we can also get melatonin in some quantities from eggs. We can get it from fish, and we can get it from nuts as a part of our diet. And so we want to do a couple of things here. These are, if you'll notice, the eggs, the fish, these are where we start to go back to animal sources of protein. So now we can see another uniqueness about these. There are some plant sources on these. They're just not as great as what we're talking about here. But in addition to setting and building a consistent rhythm in regards to the daylight exposure and night exposure, we want to make sure that we're training that natural rhythm. And this is why one of the things that I've started implementing clinically with patients is looking at wearing the blue light blocking glasses, the amber lens glasses in the evening. So once that sun goes down, we should be blocking out blue light. If we were actually having to live off the land like we used to have to do, the only light we would have exposure to was candlelight or a fire. And so any light that we're exposed to artificially beyond that is introducing blue light into our eyes or into our pineal gland and suppressing melatonin production. So that's a way we can work around that, and we can start to elevate that melatonin. This is actually something I do with cancer patients. It's a easy, melatonin has a lot of solid literature on it in applications of cancer. Clearly that's an immune system challenge, but that's one of the little techniques or tricks that we use there to get that melatonin up. And then the other thing that I was recently sharing with you about watching the sun come up, if that's possible to you, and watching the sun goes down, those are all influential in this conversation. Looking at mechanisms, we tend to think about melatonin. About all we ever hear for melatonin is that it is related to sleep. And that's not the case at all. And so I felt like it would be important to insert a few other mechanisms in here for you. So you'll see some of these biological roles that it has. It acts as an antioxidant. It's actually a very, very potent antioxidant. It does act as an anti-inflammatory. All of these are going to have immune bolstering activities. You can see anti-cancer, cardiovascular protection, anti-diabetic, weight control, protection of the nervous system, and it would logically make sense that if it's doing all of those things, certainly it's going to have an anti-aging role as well. And so melatonin is one you definitely need to put on your radar and think about what you're doing day in and day out that could potentially be affecting your melatonin levels. Now, there is a crosstalk, and this is where, just to extend and to delve into the melatonin conversation a bit here, this is where I think it's really interesting to look at how our memory, just in terms of how we take in information, how it directly correlates to the process that your immune system uses. So if you look at this, we go through this process of encoding. So you read something, you take that information in, and you're trying to initially process it. Well, that's exactly what your immune system cell does. It uptakes an antigen and one of these foreign substances, and it starts to process it. All right, the next step, step 2, is you go to sleep. And now you're taking those memories that are of a short-term nature and you're putting them into a long-term memory. You're trying to process them where you can recall them over a period of time. Well, remember, your immune system has memory. So now we're transferring that information that these antigen presenting cells had. We're transferring that information to T cells. And ultimately, what we're trying to do is be able to recall that information. So now when those immune system cells encounter that substance again, or that organism again, that microorganism, they can recall a response very quickly and start to develop the reaction that they need to overcome that. It ironically is literally just like when we develop a memory. So let me introduce another one here for you. And this is a compound called n-chlorotaurine. And this is one that I'm almost certain most people haven't heard about, because it's one that in my conversations with many professionals, they haven't heard about. So n-chlorotaurine is a compound that we can make within the body. And if you break this term down into chloro and taurine, it tells you very quickly what it is. Chloro, chloride, and taurine being probably a bit less familiar, taurine is what's known as a biologically active peptide. And so the interesting thing about taurine is that taurine only comes from animal proteins in the diet. But we take the taurine and we combine it with chloride and we make this n-chlorotaurine. Now, why is this so important? Well, it's extremely important because when we start to look at how some of these proteins that I mentioned to you earlier, that our innate immune system, this initial immune system response, some of the things that they produce, n-chlorotaurine is one of these. And so literally it can start to inactivate things like enterohemorrhagic E. coli. This is the E. coli that we associate with food poisoning that can be so disastrous and that we hear about in the news at times. That is the level of efficacy that this particular compound has. You can see that it also is beneficial in breaking down what are known as biofilms for bacteria and yeast. You'll see the last study I put down there to illustrate that. And this is relevant because biofilms they're necessary, but they're also a way that these organisms can try to protect themselves at times. And so we need a way to bust through that. And the production of this n-chlorotaurine is the way we do that. Now, interestingly, we think about salt. And if you look at what is salt, salt is sodium and chloride, but there should also be other minerals in there too. And this is the difference between typical table salt and what we might think about as sea salt, a good quality sea salt. But regardless, this is where you're getting that chloride, the chlorine chloride there. And you combine that with the taurine from that animal protein. And guys, you have your own antibiotic being produced. And it's even bigger than an antibiotic, because as I've illustrated here, this is not just about a bacteria. This is about bacteria, fungus, yeast, if you will, and other organisms that this can have an impact against. And also, just to illustrate how important this is, or how well respected this compound is, there is synthetic production of this. So this is something that is being produced synthetically and used with good efficacy. But if we provide our body the right constituents, it will make that. So next time you think about enjoying a piece of red meat, maybe a nice, delicious sirloin here, and you top that with salt, and you're feeling any bit of guilt whatsoever in doing that, do not feel any guilt in doing that, because as I've just illustrated to you, this provides all the building blocks that your immune system needs to develop a competent response. So lastly here, before we start to wind down, just some general things in relation to stress and the immune function. This is also one of the things that I very characteristically see when individuals have low total white blood cell count, so these immune system cells. A lot of times I'll go back and start looking at other indications for generalized stress responses. And these are factors that all play into dropping that total efficacy of the immune system. So however we do this, I would have been amiss if I didn't at least make mention to this. But however we do it, we've got to do things that are going to support our generalized stress reduction. And I don't make a lot of specific recommendations here. And the reason that I don't is because one person's pleasure is another person's stress. For example, just for me personally, a lot of people make a recommendation to go do yoga as an anti-stress reliever. I have no desire to go do yoga whatsoever. That does not sound pleasurable to me. However, I'm sure I do things as relaxation, and they wouldn't be pleasurable to other people. So you guys get the point that I'm trying to make here. This is a unique thing that you have to find for yourself and incorporate. Now, let me share a couple of resources that I have here for you. So first of all, if you're looking for any additional information, want to find out resources, looking for updated content that you can find in my video blog, putting out a good bit of videos right now to keep you guys updated on different topics. You can go to drarlandhill.com and find out all about that. And if you're looking for some assistance on your own, you can click that book a consultation, and we can start helping you out there. In addition to that, if you are looking for pasture-raised meats, clean meat sources, we do grass-fed finished beef, and we do it on a mixed pasture, which is, if you're thinking, well, what's the difference in that and a grass-fed pasture? Basically, what that means is that we put even more attention beyond grass-fed into what the animals are consuming to make sure that we're driving as much nutrient density into these animals as absolutely possible, so that anyone that consumes that final product benefits from that. That same conversation applies to our pastured poultry, our duck, our chicken eggs, and anything that we produce here on the farm. We don't cut corners in any way, shape, or form. I won't allow it. So with that being said, guys, I just want to say thank you for taking the time to join me this evening and going out of your way to learn. I hope that this has been insightful for you. I hope it's given you a different viewpoint than particularly what you're hearing out there. And take a look at those resources, and hopefully they'll be of benefit to you. One last comment here before I conclude is make sure that you look for additional emails coming out from my email. And the reason being there is that I am bringing one of these webinars to you guys every month to keep you updated. Next month, we're going to be talking about thyroid function. So I'll have certainly a different conversation for you around that than what is often presented. So make sure you come back next month for that. And until then, everyone, take care and be well out there. We'll talk to you soon.